This question comes from Peter, who asks, what if every person on Earth aimed a laser pointer at the moon at the same time, would it change color? The short answer is no, not with regular laser pointers. First, remember, not everyone on Earth can see the moon at once, so let's imagine we get everyone positioned where they can. Most people live between 0 and 120 degrees east, making the Arabian Sea our best betting ground. We'll pick a quarter moon at night so the bright and dark sides are easy to compare. A tiny 5 milliwatt red laser pointer can technically reach the moon, but by the time it spreads out, it covers a huge area. Even if everyone held steady aim, the effect is nothing, completely drowned out by sunlight, which blasts the moon with trillions of watts. Our combined pointers amount to 30 megawatts, 200 million times weaker. And while that may feel disappointing, it's a great moment to remind you to subscribe, so you don't miss questions that get even wilder than this. So what if we step up the power? A 1-watt laser is basically a handheld lightsaber, dangerous enough to burn skin or blind you in an instant. Imagine we spend $1 trillion to give one of these to everyone. The result? We only manage about half a lux of extra brightness on the moon, which is still dimmer than normal moonlight we see from here. Now, let's get ridiculous and hand out night suns, the gigantic helicopter-mounted searchlights with 50,000 lumens each. Focused carefully, our collective beam finally makes parts of the moon twice as bright on the dark side, but again, it's nothing compared to the blazing day side. Swap them all out for IMAX projectors, or even the Luxor Hotel spotlight, and sure, we can add some visible glow, even tint the moon with a colored filter. Nice job, team. Pause for a clap. But the sun still wins by a landslide. And if this kind of escalating nonsense is your thing, subscribe now, because we're only halfway through this ride. Let's move from toys to weapons. The Boeing YEL-1, basically a flying megawatt-class laser cannon strapped to a 747. If everyone had one with visible light, we'd finally get close to matching the brightness of sunlight. The problem? We'd also double the world's entire energy consumption instantly. Push farther. Let's put 1 megawatt laser on every square meter of Asia. Powering this array burns through Earth's oil supply in minutes, but during those minutes, the moon shines as bright as the morning sun and the surface rocks glow red hot. And we're still asking, what if we tried more power? Now, we're in pure science fiction territory. Take the National Ignition Facility's ultraviolet fusion laser, 500 terawatts in short bursts. Imagine giving one to everyone and setting them all to continuous fire. Immediately, the atmosphere becomes plasma and Earth ignites. But since this is hypothetical, let's assume the beams pass through cleanly. The moon now vaporizes at 2 meters of rock per second. Its surface turns into plasma. The plasma ejects violently into space. And congratulations, we've just invented the biggest rocket engine in history. This process, called laser ablation, literally pushes the moon. Within months, it's shoved out of Earth orbit into a chaotic solar orbit. Sometimes it slingshots into the outer system. Sometimes it falls toward the sun. Sometimes it even crashes back into Earth. Either way, we've lost our only natural satellite, and very likely, planet soon after. So, to answer Peter's question, could everyone on Earth using lasers change the color of the moon? Only if by change color, you also mean vaporize, eject into space, and accidentally doom ourselves. And if you enjoyed this wild chain of what if thinking, you know the rule. Make sure to subscribe so you're here when we tackle the next impossible idea.